we have been talking about inverses. That was the last section of our Unit 1, right? We were learning how to find the inverses. So, what is the inverse of addition? Subtraction, right? What's the inverse of multiplication? Division, okay? So, a logarithm is the inverse of exponents, is what we're going to be looking at. So, if I look at 1 and 2 right here, okay, for number 1 and number 2, I have 2 to the x equals 256. What number should be my x power there? So, I want you guys just to, like, play with this a second, see if you can figure out what number that should be. Right now, we're just, like, guessing and checking on these problems. I'll give everybody else a second. Okay? So what, and do you guys know how to raise to the power on these calculators? It is the button right above your division key. So like if you want to do 2 to the 5th power, you would do 2 to the 5th for that. And see what you get. There. All right. What is it? It is 8. Is that right? I'm not double checking her. Y'all tell me if she's wrong. Is that what you got, Lily? So x would equal 8. Because if you type in, let me just pull up my calculator here too. Okay, so if I just type in 2 to the 8th power, I get 256. So guess and check, it's 8. All right, try the next one. Is that one going to be a whole number? It's not going to be a whole number. See how close you can get. See how close you can get. That's pretty close. See if you can get closer. Let's see who can get the closest on this. I think Lily's going to be the closest on this one. I'm pretty sure. Lily, what did you get your x equal so far? Nine. Okay, this is what Lily has. 2.68014999. And if I do 3 to the 2.68014999. Got 19.000128. That is very close to being the right answer. Did anybody get any closer than that? So, but you're just kind of having to play with it, right? So, like, you probably started with like a 2 and a 3, right? A 2 is too small, a 3 is too big. So, you know it's between there. So, then you might like try 2.5, 2.6, 2.7. Then you can start adding like 2.65, 2.6. And you just keep playing with it, right? So, we could keep going and get even closer on this. But does this seem like the best way to do this? Probably not, right? It's probably not going to be the best way to get the exact answer here, because rarely has your teacher ever told you just guess and check. You know, keep guessing and checking. Usually we might start off with that, and it's a good method if you know nothing else to do, but there's got to be a better way. Now, on one, guessing and checking was much easier. We found the exact answer pretty quickly. But a lot of times for these answers, you're going to get big decimals. One thing about decimals that I'm going to tell you for this class, you guys don't take the AP exam, so this does not matter to you. But I find it to be a very good rule to apply to the situations that we're given. On the AP exam, every decimal answer that you give has to be correct to 3 decimal places. So, like if the answer is 2.680149999, you could round that off to 2.680 and leave it like that, right? And that would be acceptable. Or you could be wrong after the 0. You could have like 2.680257843, and I'd still give you credit for that answer. So I just think it's good to have that sort of standing rule. So unless I tell you otherwise in this class, I want you to always have at least 3 decimal places. If you keep more, it's always okay. If you get like one of those complicated rounding situations where you got like 9s that round, like if I was trying to round this right here to having to round that up with all those 9s, it's a complicated rounding situation. A lot of times I'll just like keep all the decimals so I don't have to deal with it. If you keep more decimals, that is okay. Less is not okay. So we want to keep at least 3 decimals unless I tell you otherwise. If I want fewer decimals, I will tell you that. So in general, 3 decimal places is what we'll do in here as well. You guys don't take the exam. It's not going to actually matter, but you will need to do that. So let's look at how to solve. Well, we're only going to solve really simple ones today. Let's look at what you will do with these. So a logarithm is the inverse of an exponential function. Okay? It answers the question, what power can you raise a number to in order to get a certain result? Okay? So I've got 2 things written here. One of them is all with variables. The other one is all numbers. So if I have a base raised to the x power, it is going to equal a. Whenever we have this b right here, I use the letter b because we call that the base of the exponent. And over here, this b right here is the base of the log. Okay, so if we rewrite an exponential to make it a log, the base of the exponent becomes the base of the log. And then you'll see the x goes over here, the a stays right here. So like on the bottom example, 5 is your base. It's being raised to the 2nd power. When it's rewritten as a log, you have log base 5 of 25 is how we would read that. Log base 5 of 25. Okay? So let's look at rewriting these. And I'm going to show you the way. I think the very best way to think about these is to think about the fact that logs and exponentials are inverses of each other. So if I have a log with a base of 3, the way to get rid of it is to make it an exponential with a base of 3. Okay? So that means over here, if I do 3 raised to, all of this is its power. Right? So I've got the same base right there. Right? This is my base of my log, so I'm going to make it the base of the exponent. That will cancel out the log completely. But if I do that to one side, I have to do it to the other side as well, right? So I would have to do 3 to the 4th power over here. Okay, and so this cancels out the log completely. You've got an 81 left over here. And we're just rewriting right now, so we're going to leave this as 3 to the 4th. All it's asked us to do is rewrite as an exponential. We're not like solving or anything yet. We're just rewriting as an exponential. Okay, both of those are true statements. They're just written in different forms. Okay, so when we see a log with a base, to get rid of that log, we can do 3 raised to that power, or whatever the base is raised to that power. So over here, Josiah, what's the base of that log, for example, 4? 5, right? So to get rid of a log with that base, we would do 5 raised to that power. Right, and that would get rid of the log. And if I do that to one side, I also have to do it to the other. 5 raised to that power. And so on that left side, everything's gone. Over here, I've got 5 to the 3rd. We're just rewriting right now, so we're not going to try to like find the answer or anything for that. I will, let me put a note right here. Depending on what answer choices look like, because a lot of times these are going to be multiple choice. Sometimes this will look this way, 5 to the 3rd power equals x. Is that equivalent? Is it okay just to switch the side of your equal sign for that? That x equals 5 to the 3rd or 5 to the 3rd equals x. That is perfectly fine. So if you're looking at answer choices and you don't see this, but you do see this, they're the same. Okay. All right, so if we want to rewrite example 5, Angel, what do you think we need to do? All right, we're going to do 2 to the power. It's going to get rid of that log right there. We're doing 2 to the power of x right here. What's going to be left on the left side, Angel? Just the 8. On the right side, what will we have? 2 to the x power. And make sure you're writing that. It's not 2 times x, it's 2 to the x power, right? You got that little exponent, the x right there. Okay. 6 is a little bit weird. Joseph, what's the base for number 6? X. So what do we got to do to get rid of the log? Okay, we're going to raise it to the power with a base of x, right? So we'll do x to the power over here, which will get rid of that. We'll do x to the power over here. What will we get for our answer? Perfect. Okay, does that make sense? Okay, there. All right, let's look at the other way around. Let's look at if we have an exponential, okay? So when we have an exponential and they want us to write it in log form, and there's a reason we're doing this. It's how we're going to solve eventually, but right now we're just getting the mechanics of rewriting. So if we have exponential and it wants to get, we want to put it in log form. For example 7, Jasper, what's the base of your exponent there? It's the 5, okay? So whenever we're trying to put this in log form, to get rid of the base of 5, we would need to use a log base 5. So what we're going to do is sort of the opposite of what we were doing in the last problem. We're going to do log base 5 of this side, and that will cancel out our 5, and we'll just have a 3 left. And if we do that, we also have to do log base 5 of the other side. And be careful how you write this. It's log. The base of the log is written as a subscript. I don't know if you've heard that term before, but it's just like a little number. It's like it's the opposite of an exponent. It's a little number that's low, instead of high. And then the 125 goes here. Sometimes you'll see it with parentheses around it in your calculator. It'll want you to put parentheses around it. Sometimes they don't put the parentheses there. It could be written either way. Okay. All right, Alex, what do you think about number 8? Okay, let's put our computers down. We don't need our computers right now, so let's shut those. If we want to get rid of that 4, how do we get rid of that 4? Okay, that is our base of our exponent, right? For exponential, the inverse of exponential is the log. So we are going to do a log with a base of 4 on this side. It will cancel out the 4. We'll just have the x. But if we do that to one side, we also have to do it to the other. So log base 4 of 8. We'll write it this way. Log base 4 of 8. Or you might see it looking like this. X equals log base 4 of 8. They might write it without the parentheses. I like the parentheses because when we start doing equations that are longer, you need them sometimes. Okay. All right. Okay, Victor, what's our base for number 9? What's our base of our exponent for number 9? It's 10. Good. So if we want to get rid of that 10, what do we have to do? The opposite of an exponential is a log, and we are going to use that same base, right? So we're going to do a log with the base of 10 here. It will cancel out that 10. What's going to be left on that left side, Victor? 3. And if we do that to one side, we have to do it to the other. So we're going to do log base 3 of this side as well. So log base 3 of 1,000. That. All right. Jasper, what's our base for number 10? Okay, it's 8. So what have I got to do to get rid of that 8? Yep. A log with a base of 8 on this side. That's going to cancel my 8. What's left on that left side? Just the x. All right, and what do I have to do to the other side? Log 8 again. Right, and so I've got log base 8 of 12. Okay, yes. Oh, yeah, I don't know why I put a 3 right there. Thank you. Losing my mind. That would be a 10. I don't know why I did a 3 there. Okay, so a big part of what we're working on today is just being able to rewrite these. It's going to be a major step in being able to solve these equations whenever we get there. So we're going to work on that. Okay, so this is not entirely necessary, but actually, let me see. When you hit log on your calculator, everybody hit log. The log button's right there beside the 7. When you hit log, does it just come up with the parentheses like mine just did there? Okay. All right. So there are a couple times you're going to need this formula right here for some different questions that we're going to see. And it's the fastest way to type it into these calculators. You can also hit math and, oh gosh, do I even remember where it's at? And go down here to A for log base, and it'll let you type it in with like a 4 right here and a 35 right here. So you can do this without using the change of base formula, but it's the fastest way to type this in. So if you have a log base b of a, it could be written as log a over log b, or you could use this ln, which we're going to talk about here in a minute. You have an ln button, you could use that one as well. It's going to give you the same answer. So like when I see log base 4 of 35, I could type into my calculator log 35 over log 4, right? So if I type that in, log 35, make sure you close your parentheses, divided by log 4, I will get 2.56. I'm going to go 3 decimal places, so I'm going to do 565 for that. Okay, the base of the log always goes on the bottom of the fraction whenever you use this change of base formula, which kind of makes sense, right? Base should be on the bottom whenever you, when the cheerleaders are building them a pyramid, the base are the people on the bottom, right? So we've got log base 8 of 4. If I want to use change of base formula for this, I would do log 4 over log 8. And so I could just type in log 4 divided by log 8. And I get, I think you typed it in backwards. You got 1.5. I think you did log 8 over log 4. I got 0.6 repeating for that. Okay. Now, you don't have to use the change of base formula. I like to, plus there's going to be a couple places where it shows up later where we have to use it. But we can type it in without it. Yes. This is just for like typing it into the calculator. So the what we were doing before is rewriting. That's going to be different. This is like a step, just if it says evaluate and you just have a log without an equal sign anywhere. The other ones we looked at over here, they had equal signs, right? So we were rewriting those. On these, they'll just say evaluate and they'll just have expressions, right? So so this is going to be different than what we were doing before. So if you prefer Desmos, Desmos of course does these too. Let me pull up Desmos here. If you go down here to functions, I think the Desmos log has an option with a log of a base. So you could type it into Desmos this way, log base 2 of 60. You could do it without the change of base formula. You would get 5.907. So you don't have to use a change of base formula, but you could. Okay? Questions on that? That's just typing it in. Okay? Special logs. There are 2 logs that show up a lot in nature that we use so often that they have given them special symbols for them. The first is the common logarithm, and that is a base of 10. We use base 10 a lot because if you raise something if you multiply something by 10, it just moves to the decimal place, right? So this is used a lot in scientific notation. It's used for really big numbers. If you have a log that just says log, just log x, and there is no base written, then it has an invisible 10 there, okay? The other one that we are going to use is a log base e, okay? It's called the natural logarithm, and e is Euler's constant. I know this looks like Euler's, but it's Euler's is how it's pronounced because it's not English. I can't remember what he was, maybe German, but that might not be right. Euler's constant it's sort of like pi, but it's a different number. 2.71828 keeps on going, just like pi keeps on going. there, and it comes from looking at exponential phenomenon. We don't really have time today for me to tell you all about where that number comes from, but it shows up in nature a lot. It's used a lot for like continuous growth, like population growth, that sort of stuff. So it's used very often. So if you see this, ln of x, and sometimes you'll see parentheses around that x, sometimes you will not. Calculator will put parentheses around it. Then this is the same as having a log with the base of e of x. And up here I should probably put this is the same as having log with a base of 10 of x. Now, the good news about these is that they are so common that the calculator's got buttons for these, right? So if I just see log 52, that's a log base 10 of 52. But you don't have to type it in that way because it's got a log button. If I'm going to type this in, I'm just doing log 52. Enter. 1.716. All right? If I want to do natural log of 8, it's the same as log base e of 8, but I don't have to use anything special because they gave us a calculator button for it. Natural log of 8. And I'm going to get 2.079. Okay? If I want to type in something like natural log of 5/8, we've got a button for that, right? So we just do natural log of 5 divided by 8 here. And we got let's see, we got negative 0.470 there. So those you just type right in. You don't have to do anything special to type those in. And in Desmos, it's the same. You just type in log parentheses 52. Close it. All right, questions? All right, let's do just a couple more things. These are asking us to rewrite. If they're exponentials, we want to write them as logs. If they're logs, we want to rewrite them as exponentials. But these are your special ones. They're either the common log or they are the natural log for this. So whenever we look at with the exponentials, you really don't do hardly anything different. Okay? If I have a base of 10 here and I'm wanting to get rid of that, right? Let's see, Scarlett, what would I do to get rid of that base of 10 right there? You'll use the same number that is the base, the number that bottom base of the exponent. So you'll use log base 10 and log base 10 of both sides. Over here, it will cancel out that 10, right? So if we've got 10 as our base of our exponent, it gets canceled out by that log. We just have an x over here. On the right side, we've got log base 10 of 60. But I just told you that 10 was a special one, right? So do I have to write the 10 there? If I write it this way, log 60, that's equivalent. That's the same thing. Because if there's no base written at all, it's assumed that it's going to be 10. So both of these are correct. It's not incorrect to write it this way. In fact, for some reason in AP Pre-Cal, they always put the 10 there, which I find odd because most textbooks do not do that. But the first one is correct, but this one's also an option and possibly the one you're more likely to see if you are looking at like multiple choice questions. All right, 18. For 18, Keely, what's the base of that logarithm right there? It's not x. The base has to be this little number right here. But does this one have one? It does not. So if your base is missing, then there is an invisible 10 right there. All right, so if your base is missing, there's an invisible 10. Okay? And so if I've got a base of 10 on a logarithm, how am I going to get rid of that base of 10? The opposite of a log would be an exponent, right? So we're going to do 10 raised to that power. It's going to cancel this out. We'll get an x right here. And if I do 10 raised to that power here, I've got to do 10 raised to that same power on the other side. So x would equal 10 to the 8th power. Okay, questions? All right. What's our base on this one, Angel? It's not 10. I said if it's missing, it would be 10, so that makes sense that you said that. But does this one even say log? It says ln, which was our natural log. And the base on a natural log is e, which seems weird because we're throwing another letter in there. But e is a number. It's 2.71828, right? It's like pi. So if my base right here is e, and I want to get rid of this, because this is a type of a log. It's just a special type of a log. Josiah, what would I have to do? To get rid of a log, we use an exponent, right? So we're going to make this e raised to that power. Okay? So e raised to that power. And so this will cancel out on that side. We'll get x equals e to the 12th. And that would be where we'd stop, right? Notice how, like, if I didn't have a log in the beginning, I end up with a log in my answer. If I do have a log in the beginning, I don't have a log in my answer. That should happen on these problems. Okay, questions so far? All right, 20. Who thinks they can do 20? Let me remind you that e is a number. All right, is this a log? Do you see an L? No. If a log will always have either the word log or ln. Ln just means log base e. So this is not a log. This is an exponential because you've got something raised to a power. So we've got an exponential right now. We need to turn it into a log, right? So to turn it into a log, we're going to take the base of our exponent. That's what we're trying to get rid of. Okay? So to get rid of a base of e, we're going to do log with a base of e. And I'll cancel that out. We'll just have 5. And if I do log with a base of e on the left side, I've got to do log with a base of e on the right side. And so that will be log base e of x. But you will never see an answer choice look like this. Because I said bases of e were a special type of log, right? It was called the natural log. What's the other way we can write natural log? ln. So we could have 5 equals ln of x right there. So it is correct to say 5 equals log base e of x. It is not what you're going to see on an answer choice. It's going to look like this right here. Okay, questions so far? All right, Joseph, is 21 a log or an exponential? It is a log. Because it doesn't say log, but it has the ln, which is a special type of log, right? So what is the base for that log? It is e, right? If I want to get rid of the log, which I do because it's telling me to rewrite it as an exponential, what do I have to do? e raised to the power. All right, that's going to cancel this out, and I've got to do e raised to the power over here. And so this will be a 7 equals e to the x. Okay, questions so far? All right, last one. Jonas, is that a log or an exponential? It's exponential, so we need to try to turn it into a log, right? And if we're going to turn it into a log, we're looking at the base of the exponent that we want to get rid of. What have I got to do to both sides? Not going to raise it to a power because it's already a power. It's already an exponential. What I've got to do here is that I've got to turn it back into a log, right? So to get rid of that base that's an e, I'm going to do a log with that same base of e. And it's going to get rid of my e over here. If I do that to one side, I've got to do it to the other as well. Log base e of 5. And so I'll just write it like this, log base e of 5. But you're probably not going to see that written that way, because there's a special log for log base e. How do I write it? Say that again, Angel. Not just the N. It's got the L with it. LN of 5. Okay, questions? All right, this feels very useless right now, but it's going to be very necessary for solving log equations, which is where we're going with this. So,